Plug a standard toaster into a wall, and it pulls about 1,000 watts. Now, imagine a single network of data centers that pulls 10 gigawatts, enough energy to power 5 million homes simultaneously. This isn't a sci-fi concept. It is the blueprint for a $100 billion partnership between NVIDIA and OpenAI. They are building the largest compute engine in human history. The scale here is genuinely hard to wrap your head around. We are talking about a physical infrastructure project that rivals the interstate highway system in its sheer ambition.
For years, NVIDIA was just the company that made the chips, but something changed. They realized that to win the AI race, they couldn't just design the brains, they had to build the body. OpenAI needs compute like humans need oxygen. By partnering directly with the world's most valuable chipmaker, they are attempting to bypass the traditional cloud providers entirely. This isn't just a business deal, it is a strategic merger of hardware and software at a scale we have never seen, and the numbers behind it are wild.
To understand the 10 gigawatt figure, you have to look at the current grid. Most massive data centers today pull maybe 100 megawatts. This project is 100 times larger. It requires its own dedicated power plants, massive cooling systems, and a logistics chain that spans the globe. It is a physical manifestation of the AI boom. But why go this big? Because the next generation of models isn't just hungry for data, it is starving for electricity. And that is where the clever part comes in.
The price tag for this ambition is a staggering $100 billion. To put that in perspective, that is more than the cost of the International Space Station. This investment isn't just about buying chips. It's about securing the land, the energy rights, and the specialized cooling infrastructure required to keep these giants alive. It is a massive bet that compute will be the most valuable commodity of the 21st century, and NVIDIA is positioning itself as the primary supplier.
But here is the catch. Building something this large isn't just an engineering challenge. It is a geopolitical one. You don't just find 10 gigawatts of spare power. It requires rewriting the rules of the energy grid. And as we'll see, that is exactly what NVIDIA is planning to do. They are moving from chips to utilities. But to understand how they pull this off, we need to look at the shift from designer to provider. This is where the story gets really interesting.
NVIDIA is currently the undisputed king of AI silicon, but CEO Jensen Huang knows that chips are just the beginning. The real bottleneck isn't the chip, it's the plug in the wall. By building their own data center network, NVIDIA is evolving from a component manufacturer into a global utility provider. They aren't just selling the shovel, they're owning the mine. This pivot allows them to capture the entire value chain of AI, from the initial design of the transistor to the final delivery of the inference token. The 10 gigawatt challenge is immense. For context, the entire state of Virginia, the world's data center capital, currently uses about 3.5 gigawatts for all its facilities combined. NVIDIA and OpenAI are looking at locations that can support this massive load, which often means building near nuclear power plants or massive renewable energy arrays. This is changing the geography of the tech industry. It's no longer about where the engineers live, it's about where the electrons are.
Reports of Project Stargate suggest a vision where these data centers act as a single, unified supercomputer, a massive distributed brain powered by NVIDIA's Blackwell architecture. Blackwell chips are designed for this scale. They feature specialized interconnects that allow tens of thousands of GPUs to act as one single massive processor. This isn't just a cluster of computers, it's a new type of machine entirely, and it's the only thing capable of training the next leap in AGI.
But not everyone is convinced this scale is sustainable. Critics point out that the energy demands of a 10 gigawatt network could strain local grids and drive up prices for everyone else. There are also questions about the return on investment. Can a $100 billion infrastructure project actually pay for itself through AI services? NVIDIA's answer is simple. The cost of not building it is higher. In the race for AGI, the winner takes all, and the winner will be the one with the most compute.
This leads to a fascinating realization. If NVIDIA controls the hardware and the power, they effectively control the pace of AI progress itself. They aren't just a vendor anymore, they are the gatekeepers. And that brings us to the most controversial part of this deal, the valuation and the monopoly. To see where this is headed, we have to look at the staggering $830 billion valuation targets and what a compute monopoly actually looks like.
OpenAI's valuation has reached levels that were unthinkable just 2 years ago. With a direct investment of $20 billion as part of this deal, reports suggest a valuation trajectory toward $830 billion. This isn't just hype. It's a reflection of the market's belief that OpenAI, powered by NVIDIA's 10-gigawatt network, will be the first to achieve artificial general intelligence. If they succeed, the value of that intelligence is effectively infinite. The $100 billion infrastructure cost starts to look like a bargain. By vertically integrating the energy, the hardware, and the model, NVIDIA and OpenAI are creating a compute moat that is almost impossible for competitors to cross. Even if a competitor designs a better chip, they still need the 10 gigawatts of power and the massive data centers that NVIDIA already owns. They are building a physical monopoly. This strategic lock-in ensures that the next generation of AGI will likely be born on NVIDIA silicon, powered by NVIDIA infrastructure. So, what does this mean for the rest of us? We are entering the era of compute as a sovereign resource. Just like oil or gold, compute will define the wealth of nations. The 10-gigawatt network is the first true AI power plant. It marks the transition from the information age to the intelligence age, where the primary export is reasoning. It is a world where the ability to solve complex problems is limited only by how many gigawatts you can pipe into a server farm.
The risks are real, but the potential is breathtaking. We are talking about a machine that could accelerate drug discovery, solve climate modeling, and revolutionize every industry on Earth. NVIDIA and OpenAI aren't just building a data center. They are building the foundation for the next stage of human civilization, a world where intelligence is abundant and cheap. It is a massive $100 billion bet on the future, and looking at the scale of 10 gigawatts, it's clear they aren't planning on losing.
The 10-gigawatt network is more than just a project. It's a statement. It tells us that the AI revolution has moved beyond the screen and into the physical world. We are no longer just writing code. We are plumbing the very fabric of reality to support a new kind of mind. And that is genuinely the most fascinating part. The scale is massive. The cost is historic. But the result? That might just change everything. The only question left is, are we ready for the 10-gigawatt future?